And we are live.
Yes! Welcome everybody! Ciao!
Welcome everyone. As you see, this time we became professional and we got microphones. I hope you can hear us. There's a number of people standing.
Okay, so tonight we're going to talk about virtual reality, augmented reality and cool stuff. As always, we have some slides at the beginning about sponsors and everything.
But first we have a couple of things to say.
Yes.
Because this is already our sixth meeting. Like it might be eighth unofficially, but it's the sixth one. And we are really extremely, incredibly, whatever. We are really happy of how the things are evolving. And we grow up a lot. We almost have 500 people, professionals, whoever you want, with the community and with the companies and the startups in the area. And that's the reason why tonight we have a number of people that are going to present to you who they are and what they're looking for. So they want to hire you, they want to give you an opportunity to work for them, to do an internship for them. And that's even more important, that's exactly why we built Speck&Tech. So now we go on and we proceed, but keep in touch because the things are moving on faster.
Awesome. Okay, so thank you everybody for being here tonight. As always, our sponsor, let's roll it fast. Okay, Impact Hub, we are here in this place which is called Impact Hub, here pointed with the laser. And they offered a special deal for people who want to stay here. We have offices and stuff and places and whatever. If you need a place to work, you can write Impact Hub with this special promo code, which is Speck&Tech Spacca. For the English one, is like Speck&Tech Rocks. So, yes, warm applause to Impact Hub, which is heavy sponsoring us. Without Impact Hub, Speck&Tech would be impossible. So, if you want to stay here, write down an email with the promo code and you could have a huge discount. Awesome. Then, since the other company which is heavy sponsoring this event is Becca, which is my company, we just released a game app which is called Tricky Traps. You can try it somewhere there with a tablet. This is just heavy bad sponsoring, sorry. And and then, Franz?
Yeah, sorry, my microphone wasn't working. One of the reasons why we built Speck&Tech is that we want to promote innovation and entrepreneurship. So people that really have an idea in mind, we would like them to bring it on the market or to validate it to see if this works or not. And this event is the same designer that designed our logo of Speck&Tech. And it's an event that I'm co-organizing, and it happens in 6 different cities around Europe from the 2nd to the 4th of December. It's called EIT Alumni Startup Days. It happens in Stockholm, Paris, Berlin, Barcelona, Eindhoven, and Lisbon. So check out our website. It's called startupdays.eit.alumni.eu, and we can tell you more later. These microphones are working.
So, enough with the boring sponsor. Now our favorite sponsor as usual. Warm applause, Segata. Yes, they bring you the spec every time. This time, for the first time, a vegetarian option, which is cheese. We don't have the equipment for vegan people, but we're arriving at that. And then I want to invite Agostino here from Practix.
Can you hear me? Yeah. Okay. Yes, I'm Agostino Cinelli and I work at Practix. And who are we? We are a spin-off born in 2010 and raised in FBK, pixelated FBK. And last year we moved in Rovereto at Polo di Meccatronica, and we are one of the companies in Polo di Meccatronica now. What we do? We develop innovative and interactive application for multi-touch devices, especially for large touch screens. And we made application for museums. This is multi-touch interactive table application made for the Ozzi Museum in Bolzano. We also developed a couple of applications for Muse here in Trento and some other application for other museums. We developed a media presenter and a dozen of table games for an American company that builds ocean ships, and games like hockey, memory, checkers, blackjack, and installed and running on the ships. Our main project is Touch Domain. It is a social content presenter. Touch Domain runs on interactive tables, large multi-touch monitors, and video walls. It's also a digital signage for both indoor and outdoor monitors, and they're all connected to the cloud. Touch Domain is social because if I use my smartphone to log in to Facebook, and let's say that's me, pixelated me, I like Speck&Tech, this information is sent to the cloud, and the cloud send this information to all the screen, and they all display what I like. Okay. How we do that? We developed Touch Domain using C# and WPF with MVVM. Sorry, but the size is wrong. Okay. We developed a web application backend using HTML5, JavaScript, Angular, and some technologies like Web API, WebSockets, and etc. And we use Microsoft Azure and some cognitive service of IBM Bluemix services. Why are we here? Because now all the devices that want to run our software needs to have Windows installed, and this is some limitation. And what we want to do is make this cross-platform. And we are here to offer a 6 months paid internship, and we're looking for a developer or man or woman who has a strong knowledge of HTML5, JavaScript, and Angular, or a framework like Angular. And if you know the others I talked about before, we are happy. Okay, if you think you are the one we are looking for, send us a CV, or if you want more information, feel free to ask me or Daniel. It's the CEO of Practix, and thank you.
Thank you very much.
So guys, do you hear? Basically, these guys are here to hire you, and it's not like a 3 months internship at the university doing whatever the PhD is telling you, but it's a 6 month internship paid in a company. So I think it's definitely interesting, and you should contact him at the end of Speck&Tech, this guy here, or we will promote it the next days over our channels.
Yeah, you can find all the contacts on the website, Telegram channels, and whatever as usual. Then, next event, we already organized the date, which is incredible for us as well, which is the next 13th of December. Yes, awesome. As always, you can find all the information about the stuff on our website and Facebook and Telegram channels. Now, let's start for real, augmented reality. We have the first speaker from Horus. Big applause.
Okay, does this sound good? Okay, perfect. So, hi everyone. So the topic of today is augmented reality. What I'm gonna do actually, I will talk a little bit about what we're doing and also try to, we're not doing virtual reality as one would imagine, usually like with helmets and so on. But what we're doing is that we're trying to make the world accessible for blind people. So we are using sound to describe the world to them. So, first of all, there are in the world almost 285 million of people who in some way are having issues due to sight loss. And of these people, almost 40 million of them are completely blind. And unfortunately, these numbers are estimated to grow by 2020, according to some statistics. And the thing is, due to old age or other kind of illnesses that cannot be cured, so unfortunately these numbers are not gonna disappear. So what we thought is to design a system that could help them in understanding the world and in making the world accessible to them. So this system is called Horus, and it's a wearable device for blind and visually impaired people. And we like to call it the wearable personal assistant for the blind. So basically, it's a system composed of two parts. We have a wearable headset and a small pocket unit. The wearable headset has a stereo camera system, microphones, an IMU, and a stereo bone conduction system. And the user just wears it on the head. And what it does is that it basically acquires images and streams them to the pocket unit. In the pocket unit, we have a processor designed and developed by NVIDIA, which allows us to run very powerful computer vision and machine learning algorithms that basically translate these images into sound. So a little bit of history before going into the actual technical stuff. The project started in February 2014. From me and my partner Saverio. We had just finished our bachelor project at that time it was like mobile robotics. So we designed a system which allowed a small robot on the ground to move, avoiding obstacles using a stereo camera. And on one day we were in Genoa, just in front of the train station, we met a blind person. And this person basically had issues in moving around. And that was because we learned, after helping him, that that person had built some sort of mental map of all the square in front of the station. And however, on that day there were roadworks and a lot of traffic and noise, so he couldn't move around. What he was doing basically was just following the corners of the buildings, and he knew that after the fourth and the fifth corner, he could find the pedestrian crossing and then go to the bus stop. So after that encounter, what we did was start thinking about, okay, why don't we start taking the technologies we are already using for robots and then bring them to help blind and visually impaired people. So from there we started, and the first things we did were to go and talk with blind people directly. Because I mean, we had some ideas, we knew some kind of approaches to solve their issues, but I mean, the right kind of person who can tell you exactly what they want is your users. So we started meeting with blind people, associations for visual impairment, and along with them we started building what would become the device that we have now. After that, as soon as we sort of consolidated our assumptions, we started also taking part to contests and also acceleration programs. And actually the first one we won was organized by, at the time it was EAT City Labs, now it's EAT Digital. And we won in May 2014 in Eindhoven, in the Netherlands. And that first grant was like 15,000 euros, basically allowed us to create the company and then also hire the first people to join us in our project. Then basically fast forward from there, we applied to other acceleration programs. One was the Working Capital Accelerator by Tim. Took part in other contests and other activities. We were awarded the prize as one of the most disruptive companies by MIT Technology Review Italy. And in January 2016, we managed to receive a seed investment by Five Lion Holdings, an American company, of $900,000. And with this investment, basically, it allowed us to change how we were working. Because before, we were relying on grants and all those small contests. With the investment, we were able actually to start working with external suppliers. At the moment, we're actually working with somewhere like 7 or 8 different companies, all in China. And also grow as a team and hire more people. Currently, we are almost 50. And where we are now is that we have like almost a beta version of the prototype. We've made a lot of iterations. And during this process, we never lost contact with the people. So whatever thing we did, whatever modification we did, we then tested it with people. We made them try the mechanics, the prototype, how it felt, just to validate what our assumptions were before making that change. And this is basically where we are now. This is a picture of one of our first prototypes. It's not actually the very first, because that was very, very ugly, uglier than this one. But at the beginning, the idea was to have a system which could be just clipped on a pair of glasses with the stereo cameras and then a wire that just went to the pocket unit. In the end, that idea basically changed like after, I would say, 7 to 8 months, mainly because we noticed that, I mean, not every blind person wears glasses. So from there, we decided to change a little bit our first ideas, and then we moved to a different design, which is now based around the idea of a headset. So this is basically what it will look like in the next couple of months. Right now we have prototypes we are building with commercial components and also some custom stuff that we are making from the suppliers that we have. So, end of the story. How does it actually work? So currently, in the current release that we have, the user just has a menu. He selects the whatever functionality he wants. We have a list. I will go into that later. And after he starts the application, it's very much similar to smartphone apps. The application starts, it started processing the images, and then usually it describes, it gives feedback to the user either automatically or thanks to some user triggers, which could be, for example, pressing of a button or just bringing an object just in front of the cameras. And what it actually does, and the features that we are developing are several, mainly because the different types of visual disability ask for different types of help. So what we thought is to design something which is flexible and can assist both visually impaired and blind people according to their kind of disability in their daily life and throughout the whole day. So we're working on text reading and face and object recognition, mobility assistance, and scene description. Here we are basically combining standard computer vision, standard and classical machine learning, and more advanced techniques which are like hot topic at the moment, which is basically deep learning. All on the device locally, so without the need of any kind of cloud infrastructure. So going into a little bit more detail on the different functionalities. For text recognition, we are working on 2 levels. So the first one is actually understanding from the images the presence or absence of text. Because usually, I mean, standard like OCR engines, you just take a page, you run it into the scanner, and then you run the OCR on top of that. So you have like high resolution images, always flat, always with a good contrast. Whereas if you're using like a mobile camera, which only reaches like 1080p of resolution, so full HD, it's definitely harder to get a good image out of it. And also, since you are working with blind people, but also if they were like sighted people, if you don't have feedback of what the camera is seeing, it's hard for you to actually bring a piece of paper just in front, in the center of the field of view of the cameras. So what we're doing here, first of all, is that we are giving audible feedback to the person. Right now it's pretty simple. If we detect that an obstacle is in front of the cameras using the 3D information, and then if the object is like too much to the left, we create a sound which comes like from the left earpiece. If the object is too much to the right, we move the sound to the right, and we similarly also code for height by using the pitch of the sound. So a low text is translated into a low-pitched sound, and a high text, so something which is very high in the field of view, is translated into a high-pitched sound. Then, when the text is at the center of the field of view, we have a confirmation sound, which now is a bell, basically. And then after that, when the object is stable, we then grab the image, run our text detector on top of that, and then basically apply some pre-processing operations to make the text look as much as possible like a scanned document, so that then like standard commercial OCR engines can then recognize the text, and then we synthesize it back to the user using a standard voice synthesizer. For face recognition, it's a little bit different. We do not have any kind of centering issues in this case. What we need to convey to the user is the fact that the cameras are seeing either a known or an unknown face. And also, what we want to give back to the people is the fact that when the cameras detect that there is a face, you need to be able to tell that to the user without every time having to tell him, okay, I'm seeing one unknown face, or I'm seeing 2 unknown people, and so on. So the kind of idea we are testing now is that we are using sounds to, like, very small notification sounds, some small pops, to tell the blind person that the cameras have detected something. And if the pops are followed by the name of the person, then it means that the device has actually recognized the face of the person. Otherwise, if there are pops with no name, it means that, okay, I've seen a face, I don't know who he or she is. So if then the user presses the learning button, then he can, actually the device just grabs a bunch of pictures from the face of the person, asks you to record the name, and then the learning process happens, and then basically you can then recognize him or her afterwards. So the goal here was to have something which is not always there in a obtrusive way. So something that is always speaking to you, that basically gives you like headaches because it's too much there, it speaks too much. So we chose to combine sounds and also small, like the recordings of the name, just to tell the person who the cameras are seeing. Then in a similar way, we have object recognition. So in this case, we are exploiting a lot the fact that the device can see in 3D, basically, because what we're doing is that we are understanding the fact that there is something in front of the cameras, and then triggering the recognition functionality. So this is kind of an example. You start from a stereo image, then you get what it's called the disparity map, and then the relevant point cloud is basically just like humans see with 2 eyes, we are doing the same with 2 cameras, and we try to create a 3D view of what's in front of the cameras. And in a similar way, like we are doing with text reading, we have to help the blind person bring the object in front of the cameras and at the right distance. So we are basically currently employing the same kind of strategy we are using for objects. So if an object is at the edges of the field of view, then we create either low pitch or high pitch sounds, and the same for left or right. Then mobility assistance means that we are heavily exploiting the 3D vision capability that we have with the cameras to detect obstacles when the person is moving. So to do that, we basically are acquiring, again, 3D images, the 3D point cloud, and then we are projecting that into the ground plane. And on that, we are sort of separating the space in front of the person in three sectors. We have like a left, central, and a right sector. And each one of these sectors is also separated into several distance levels. And every area that we define in this way is then coded into a different sound. So one of the approaches we have tested was to do something very similar to like the parking assistant. So we have like, if we have an obstacle coming from the left, we generate a sound coming from the left, which gets like faster and faster the closer the object is. We are also testing several different other approaches, but we found that this one, albeit it being pretty simple, can still be used like by blind people to move around and understand if they have an obstacle in front of them or to the right. Then the final one that we have is scene description, which this one basically relies a lot on deep learning. Here we are using both convolutional neural networks and recurrent models to extract features from like the full image or just a small portion of it. And then we run these features into a recurrent model that basically what it does is it generates a short caption for the image. So usually it works very well with computers. You point to a computer with the cameras, and what it does is that it says that it sees a computer on a table. Usually that's the kind of output you get. So this is a short video that was shot by NVIDIA at our place, and it shows a little bit how the functionality works inside the device itself. Apart from my face.
So it learns as the user shows this object, yes?
Mm-hmm.
Not predefined network that recognize.
Yeah, we do have some predefined objects, but the idea here is not to try and learn every possible object, but just give the user the ability to learn by itself. Now you should show a little bit of the disparity map I was talking about. So, I mean, we are using cameras with a very small baseline, which is the distance between the two cameras themselves, but we can still achieve pretty good accuracy. Like red things are very close to the person, while blue things are very far. I don't know if we can hear that.
Each sentence that tries to describe what's in front of the blind person. All of it is obtained through deep learning.
A group of people sitting around the table with laptops.
Okay, so this was one of the captions that was generated by the model we are using. So it depends on how you train it and how much data basically you feed it. But the idea is to generate short sentences that, for example, you're a blind person, you're entering into a room, you want to know what's going on, so you just trigger that, and then it tells you the best approximation it can get for what the cameras are seeing. Okay. Good. Okay, so we're almost at the end. So this was the general idea about what we're doing, how we're doing it also in some way. With these last few slides, I would like to share with you some of the major lessons that we learned, or yeah, basically something that we learn either like the hard way or just from experience. So the first thing is to talk with people about what you're doing, mainly because if you you have an idea, you have some assumptions about what to do, they might be right, they may be right, or they may not. So the best thing to do is to talk with people who are in the field, people who aren't users specifically, just to get like a more in-depth understanding of what's going on around in the field, if there are like other companies or other teams doing the same stuff, or if the idea you came up with was already completely developed by something else, or if you actually had a super great idea, and it might be that by talking with people you find someone else that would like to join you and then go along with you in this venture. The second stuff, which is similar to the first one, is to talk with, look for advisors and mentors and talk with them. Mainly because, especially in the very first stages, they can help you at least avoid the most common mistakes. Because, I mean, they've already gone through that. They can try and foresee at least some of the stuff that could be happening. Of course, they won't prevent all the mistakes, but also, I mean, what I like to think is that, I mean, doing mistakes is the best way to learn about stuff. So they will help you avoid the most common ones, or also the most, like the deadliest ones. But I mean, they will bring a very good value to the company. Then the third point might seem stupid, but it's to write everything down. I mean, I've learned that myself, because it might be that sometimes you have another great idea or a deadline or something that you should do, then at that precise moment you think, okay, I will surely remember about that. Then 5 minutes later you get 10 emails, then another person calls for you, then you are in a call, and then like 99% you will forget about it. So if it was a good idea, you will lose it. If it was a deadline or something you had to do, you will forget about that, and when you remember about it, then it will be definitely worse. So like using whatever shared note-keeping stuff, calendars, whatever tool, I think, I mean, it helps a lot also in, yeah, keeping track of stuff and then not forgetting about things. Then fourth point is that hiring is super important. Everyone talks about it. First of all, because it's not like a one-man show, and also it's not possible to build things alone. Mainly because there are so many different aspects that you have to think about, is development, talking with suppliers, in our case then certifications, sales, then communication, customer care, and the list basically grows on and on every week. So, but apart from saying the like normal stuff about hiring, I mean, finding the right people that can be fitting to the company and the kind of culture you are creating, one of the recent experiences I had was, I mean, sometimes it happens that you have to, I mean, more often than usual, it happens that you have to hire a person who is completely not in your field of expertise. Say, for example, you are a standard high-level developer and you need to hire a firmware developer, or someone that knows about like embedded and how to build embedded systems, or you're an engineer and you have to hire a marketing person. And one of the issues I faced, and I think many people faced, is that you don't exactly know how to evaluate them, because they are so in a different field that it's hard for you to actually judge whether they could actually bring value or not to the company. So what I started to do, and I also found some other like blog posts of other people that wrote about that in the internet, is just to you know, take 1 or 2 weeks and then try that thing myself. So, for example, for like a firmware position, just buy a demo kit, try and follow some of the samples that are there, or for the embedded position, okay, you start reading about that, trying to understand what kind of tools are used, what kind of things you can do. I mean, there's a lot of stuff on the internet, pretty much on GitHub, or you can find also some pre-made stuff that can help, that can quick start you very quickly to just get an idea of basically how stuff works. So, and after doing that, what you get is a very, very small understanding of the topic, of course. I mean, in 2 weeks you cannot become like a genius at something, but at least I think it will help you a lot in understanding at least in what kind of field you are going into, and even if for a little bit talk the same language as the person you're trying to hire. And then the last one is, I think, always have a plan B, and in brackets possibly also C and D and so on, mainly because usually, I mean, it's strange when everything goes as planned. So you might have ideas, okay, that supplier needs to deliver by November 10th, for example. Then you talk with them on November 5th and they tell you, okay, but our engineers were very busy, or they were like this kind of holiday season, so we cannot deliver. Or you were planning on some kind of feature to be ready by some date, but then it's not. So what we are trying to do when we work is to, okay, we have one major milestone, one major goal, but what happens if this kind of goal, we cannot reach it for any reason? So what do we do? When do we decide that when do we decide that we have to switch to plan B? And so usually when we plan stuff, we decide one goal, but then, for example, this happened with suppliers. We often talk with several suppliers at once, trying to be sure that at least 2 of them were able to fulfill our requests, so that then if either one of the 2 couldn't deliver by whatever reason, then we would have like a backup choice. Of course, this is not something you can do every time, money reasons, time reasons, whatever reasons, but it helps. I mean, if you analyze what you're doing, decide which is most critical and most prone to failure, you should then allocate your resources to that, so that even if it fails, you have a backup solution. And then that's basically it. That's the end. So I was here to talk about augmented reality, but actually I'm also here to look for potential new hires. So I'm here like kind of both aspects. So if any of you is interested in working in computer vision or machine learning, who knows a little bit of C++, actually we're also looking for Android, iOS, or Xamarin developer. That would be best. Possibly also some backend developers with Python. They're using Django as well. So basically, if you are interested in technology and software development in general, because I mean, we are covering pretty much all of stuff, you can just write an email to me, to the company, or just talk with me after that. Or to Speck&Tech. Or to Speck&Tech, of course. And then, I mean, I'll be more than glad to have a chat with you. Thank you.
Okay, thank you, Luca. It's incredible because last time I met him, it was 2 years ago, and I was in Berlin, and he was in the Netherlands to receive this prize from Yeti Digital for the $15,000. So before starting, my question was, what's your partnership with NVIDIA? Like, you're still, like you run by yourself? You're independent, or they're just a partnership? They're funding you somehow, or what?
No, we are completely independent. Actually, the fun thing is, if I remember correctly, the kind of contacts we had with NVIDIA was because my partner Sabirio was in San Francisco at the time, And we knew one person, which then knew another person, which like a sister, if I'm not mistaken, working in NVIDIA. So he basically then was invited into the office, and there he met the people, and from there we started. But apart from the fun stuff, I mean, we're completely independent. We are actually using their technology, and they are happy that we do. So that's basically it.
Have you patented your technology?
We have made some patent applications, yeah. It's hard to patent software, especially in Europe. We have done something for the hardware and the general assembly and user interface. But it's like a long process, so we're still working on that.
Have you had any, have you had any privacy problem in your application, especially with the facial learning part?
Well, privacy, well, not yet. First of all, because we are not on the market, so probably no one is interested into kind of suing us. But what we're doing is, I mean, we're not storing any pictures of the face, just some kind of hash. It's almost a blasphemy, but we're just extracting features from the image. So we are storing them, so we cannot reconstruct the face from the features. We can just verify that the face is actually that face. But in any case, I mean, we will do whatever is necessary to be safe.
Any other question?
Okay. Okay.
So you're learning features, like if you give this to a blind person, it's going to recognize their new friends, because it will say, ah, this is a face I don't know, and the person will speak, and will say, ah, that's Paul, so it will extract features and sort of hide them.
Yeah, the idea is that one. I mean, we of course we cannot have like every face already on the device. So the idea is you meet a person, a friend that you know. Then the first time the device will tell you that it's unknown. Then we have like one dedicated learning button which triggers the learning part. And after you press it, it will just gather some images. Then it will ask the user for the name of the person. So we just then store the recording and we associate it with the features.
So are you using preset?
Sorry.
Are you using features you've already learned somewhere else and just making a mask of that particular face, or are you actually learning new features as you go?
No, the features, we have a pre-trained model which always extracts the same features so that we can also compare them between different faces.
Yeah, so it's almost like a new histogram for the face.
Yeah, I mean, a histogram could be regarded as a feature, so yeah.
And what NVIDIA card chip are you using?
It's the Tigra K1, so we are like with the old versions.
I've got another question. Why did you decide to remain in Italy, to fund your startup in Italy instead of going to the US, for example?
Well, we already had a lot of contacts here in Italy for like with associations, some blind people. I mean, before getting the investment, we spent like 1.5 years talking with associations, some blind people. So, I mean, that's one of the major reasons, I would say. We had a lot of contacts and people who already knew about us, so it would have been sort of stupid to go away.
So your next step will be to validate the model, bring it on the market, and then expand it later?
Yeah, the idea, I mean, currently we will start some kind of beta testing phase by the end of December. As soon as we get the new boards, we will be able to give a small number of devices to blind people just so that they can use it at home. And the goal is then to start marketing and selling it by March or April of next year, according to like certifications and other stuff that we have to do.
Well, thanks again to Luca. And last question, like.
You showed us the first prototype, and it was basically a pair of glasses with a device attached. But then you change it, and now it's a headset. But it doesn't look very comfortable for people who actually wear glasses.
No, you can wear it. I mean, it's like a pair of. Well, I have the headphones here, so I can also lend you my glasses if you want. But actually, I mean, it's like a it's the same kind of headset that people use when they go running, like Aftershocks headset, or also Panasonic, I think, does them. They just go like over your ear, and they actually have some clearance for glasses themselves.
But actually a good question, and while every one of us is gonna be eating Speck, you can stay there and try his model of glasses if you like. But yeah, he brought a model of the glasses, if I'm not correct, right?
Yeah, no, actually, I mean, I have here the prototype.
So
as well,
later on, you can just try it, and I think he's gonna show them up. And
yeah, either on my computer or we can do something.
Yeah. So, yeah, again. Thanks again to Luca. That was really inspiring, and guys, it's the second time tonight we offered you position of internship and jobs and whatever, so please go home, find a job, apply, because it's exactly what we're trying to do, and thanks again to Luca.
Thank you very much. We have now 5 minutes of break. If you want to go to the restroom, which is there. If you want to grab a beer, which is there. If you restroom, not restaurant. See you later in 5 minutes.
Io vado a buttare questo da qualche parte.
Puoi dare una bella accelerata.
Lo so, è lungo il cavo.
Ciao mamma!
Ciao gatto! Gatto
Speck&Tech is restarting. Please sit on your chair. Dun, dun, dun. Please sit on your chair.
I like red boat. We're landing in Verona this time. 7 wings time, wind, 7 o'clock, running 55 kilometers.
The exit door.
All the people drinking too many beers at the end of the room, please move your ass.
Your ass.
On your respective chairs.
Your belongings. Okay, so last guest for tonight. We're presenting you Francesco Alzetta. Big warm applause. This is his first time talking in public. He's very scared. Good guy. So he's gonna introduce you to the joy of doing stuff with virtual reality, as experienced with HTC Vive, which is the coolest and hottest technology of the moment for virtual reality and stuff. But let's give him the stuff so he can speak to you clearer. Let's go!
Thank you. Julia just spoiled me everything. Hi everyone, my name is Francesco and I'm a student of computer science here in the University of Trento. We are here tonight to talk and discuss about augmented reality and virtual reality. We have just listened to a wonderful talk about augmented reality, so wonder. Guess what? I'm going to talk, maybe something went wrong. Oh, yeah, thank you. I'm going to talk about virtual reality. So, first of all, I want to ask you if anybody of you has never heard about what a head-mounted display is. Raise your hand. No, never. I say never. Yeah. Oh, wonderful. Yeah. So we can move on and let's see what are the key points that I'm going to discuss this evening. The first one is a couple of interesting uses of virtual reality nowadays, because we know that the most known use of virtual reality is in video game, but it's just, as I know, only the most known one. There are a lot of fields where virtual reality could be employed in many interesting things. The second one is the analysis of some health issues correlated to VR, and we will see some methods to reduce or avoid these problems. The third one, is a brief presentation about VR parachuting, which is the app I developed as my bachelor thesis. And we will use it to analyze some problems that you can encounter with respect to programming canonical video games. And the last point that I see is covered, we are going to see some tricks that I made to improve the computational load of the GPU and the CPU. So, this is one of the uses of virtual reality that I love most. It's a concern merging architecture and virtual reality. Imagine that you are going to buy a new house and you can travel in it and say to the architect, I want the furniture this way, I want the cooker there or there. So the possibility to be in a building that is not even built yet and decide how it will be built. Yeah, I think it's very interesting, this use of the virtual reality. And the second one is this one, NeuroTouch. NeuroTouch is a virtual reality simulator of surgery that allows aspirant surgeons to operate on virtual bodies, because doing the same operations on real persons. So, you know, making a mistake here would be different than making a mistake on a real person. This is really an improvement, I think. But there are some issues with virtual reality. If you have ever tried a virtual reality experience, you know. And these are the main ones. So headache, stomach awareness, nausea, sense of vomiting, disorientation. All of these can be grouped on one single term, that is cyber sickness. But what is the main cause of the cyber sickness? Ears. As a matter of fact, in our ears there are three semicircular canals filled with a liquid, and this liquid moves with the head rotations. When moving, this liquid pushes on cupula, which translates mechanical movements into electric signals. So there is disparity between the visual stimuli and the vestibular stimuli, and this causes the brain to blow up. So ears are very bad for us. So there are some requirements that you have to be aware of if you want to reduce this problem, and are these ones. The first one is a wide field of view, greater than 80 degrees if possible. The second one is an adequate resolution greater than 1080p, and the third one is a low pixel persistence. The pixel persistence, sorry, is the time spent by the screen in changing the color of the pixel. So if we have a high pixel persistence, we obtain a motion blur effect. Yeah, so we see all blurred, and then, you know, we have a high cyber sickness if we have this. And then also high graphic tracking accuracy, and high graphics refresh rate are important to avoid this issue. Especially high graphic refresh rate is important because you know, in canonical video games 30 Hertz are enough, but are enough for traditional software because that stimulates fovea, so the central vision, but they are too low for peripheral vision. And last thing to say is that the intensity of these problems changes from person to person and from their health condition. For example, if you have a earache or if you are tired, you will be affected more by the cyber sickness. There are also some tricks that you can use to reduce even more this problem, and are putting static objects into view. Static objects like a virtual cockpit or a virtual nose. This thing of the nose is strange, but is really interesting, and it could help because although we are not aware of it, our eyes and brain have constantly perception of the nose, and deleting it from the sight could cause the cyber sickness problem. I know you are wondering why Voldemort is not puking every time, but you know, he's a wizard, he's a badass wizard, so he can do everything. So let's talk a little bit about VR parachuting. As I said before, this is the application I made as my bachelor thesis, and his main purpose is to help people that suffer discomforts as dizziness to reduce and face them by the reiteration of the experience. So I made it in Unity 3D, and I developed two different versions. The first one uses Oculus Rift and an Xbox controller, while the second one, that I think is the coolest one, uses the HTC Vive. Why I said that the second one is the coolest, it's because the two versions are quite the same, but the HTC Vive comes with two wireless controllers that allows us to interact with our virtual environment. So it gave me the possibility to, for example, pull the handle. Yeah. To pull the handle to open the parachute, and the handles to manage the sail. Then in my parachuting experience. So. Yeah, it's going. What? And the gameplay is a little speed up mainly in the traveling and falling part for time reasons, because the entire experience would last a quarter, 20 minutes. Hey, this is not my verse. Yeah, I tried to mask it, but it's me. I'm a little upset because the gameplay is a little cat, but I think you can understand what is going on. Yeah. It's all working in real time. It's only 3 minutes, don't worry. It's not so long. Yeah, wonderful. No, this is the land where I was born, obviously, because... No. You know, when you go the first time on Google Earth, you went to visit your house, and that's the same principle. I took the place where I was born. I apologize.
With your headset.
Perché spendere 180 euro per andare qui con un po' in camera?
Yeah, as I said, borders are a little cat, but I assure you, I'm effectively managing the sale. Even if you cannot see it from this video.
Have you ever tried suicide?
Yeah. I have put the ragdoll also, and if you don't open the parachute at a certain altitude, ragdoll will activate and you fall down, and then a black screen telling you, oh, you fool, you are dead, you're dead, comes out. But here I prefer to show you a successfully landing.
Congratulations.
So, I want to ask you if someone just noticed something strange in this video, apart from my voice, obviously.
Where are your hands?
Wonderful. There are no hands, no arms,
Nobody.
and no head.
Nobody, yeah.
Yeah, the body was, but without arms and head. And that's because of the so-called creepy-proof phenomenon. And what is it? It is the fact that happens when you don't have a physical constraint of your body part. So, for example, if I approach the helicopter, I and I put the arm in it, I have not a physical constraint, but the arm effectively glitches with the helicopter, so having a compenetration. And we know that we are stupid when we are playing video games, so we found funny to do things like, I don't know, put an arm through our head or something strange. And so I've cut this possibility to the root. And that's where most of you are experienced, if you have ever experienced one. It doesn't have even the body, if you noticed it. You found yourself floating like a ghost in midair without no legs, no body, and that's because this clipping through phenomena. That, of course, is bad for immersivity and this kind of things. But have you ever wondered how camera works in first-person video games? Basically, what is usually done is parenting the camera object to the head of the avatar, and then move it a little ahead. But what does parent the camera to the head means? It means that in Unity and other 3D game engines, when you parent an object to another, you will basically make that object son of another one. So all the translations, all the modifies that we do on the father will be reflected on the son. So when I parent the camera to the head, all the movements that the head does, also the camera does them. And this allows us to have a camera that moves with our avatar without a single line of code. So this is really fantastic. But there is an issue. This issue comes out when you are going to animate your avatar. So when you are, for example, running or jumping or dancing, the camera also moves with you. So this effect is called head bobbing effect. And this is really awesome when you are playing with canonical video games, because it gives you an idea of a more immersive idea. But when you are designing an app for virtual reality, no matter if you are the best sailor in the world, you will puke, because I assure you that you could last, I don't know, 30 seconds, and then you will puke, 100%. So. Did you try it? Huh? Did you try it? I tried it. On my skin. Was it fun? Huh? Was it fun? No, I had to rest for an hour, and then I could go on, because it's terrible. So what I've decided to do is to unparent camera from the head and parent it to a new empty game object. As you see, yeah, not going. However, is the highlighted one, camera setter, and this way I got rid of this head bobbing effect. But the problem was that avatar moves and camera stuck, don't move, because it's not even parented to the head. So I made a script and I attached to it, which allows the camera to move with the avatar. And remind the fact that I wrote a script for the father and not for the camera, because we will come back to this later. So here's the script, and as you can see, I have a reference to the head of the character and to the character himself. And the type of these two variables is the transform, which is a component that every game object in Unity has. It contains the position, the rotation, and scale of the objects, and stores their values in a vector tree. A vector tree basically is an array of size 3, which contains the x, the y, and the z value. So at the very start of the app, I initialize the vector tree highlighted, which is the distance vector between the initial position of the head and the position of the camera. So I take this distance because I put the camera here initially and I calculated this distance. Then, at every frame, I call this function, which purpose is to reposition the camera in the right place with the right rotation. As we can see here, almost. If we are moving, at every frame I reposition the camera, summing from the position of the head this distance that I calculated at the start, and I do quite the same for the rotation. And I said to you before to mind that I've attached the script. The script to the fodder and not to the camera, because if I had attached it to the camera, resetting the position at every frame denied to me the possibility to move the head, while attaching it to the fodder resets it in front of the avatar, but then Unity will sum my rotation of the head, so I have not constraint. So we talked about these problems with the camera, and let's now see how I could reduce computational load in my application. Why I need to reduce it? It's because, as we saw, the requirements to limit serious problems like cyber sickness are really high, and this is reflected in the fact that optimization and resources management must be primary goals when designing and programming for a VR experience. 60 Hz and 1080p and so on. It requires high computational load. So the first one is speed trees. But what's a speed tree and how does it work? Speed trees are a set of special vegetation models that have, for every tree or bush, different models from the one with the highest number of polygons to the bidimensional one. And the interesting thing is that you can set some thresholds and say to Unity that, for example, when I say I mean the rendering camera is 10 meters from the tree, from that tree. I want it to be the most beautiful tree of the set and to have real-time calculated shadows and to have realistic realistic reactions of the branches to the wind and so on. Then I could say if I'm 30 meters from this tree, I want it to be a less detailed model. I don't care about shades. And if I'm 100 meters from it, I just be happy if you put a 2D image, because I don't even notice it. So this helps to reduce enormously the GPU load, because it has to render only a few polygons and not all the high resolution trees of my forest. The last one is the playing area, and because I don't know if its extension was understandable by the gameplay video, but it is at 60 by 60 kilometers, real kilometers I mean. So with Unity tools, it would have meant destroying completely performances and frame rate, due to the fact that it would have too many vertices to calculate at every frame. So, and another issue with Unity terrain is that you could at maximum have a 2 kilometers by 2 kilometers terrain. So you can imagine that if I want a 60 kilometers by 60 kilometer terrain, I would need a lot of terrains and then merge them together. So what I've decided to do is the following. I uses this free tool available at the link terrain.party, which allows me to choose an area, which, as I said before, is the land where I was born, and outputs me a PNG file that, on a grayscale, gives me information about the altitude of the area I have just selected. Then, with this file, I could, in 3D Studio Max, create a model which reproduces exactly my land. And at this point I have a model, but I have not a texture to apply on it. So I asked for help to our beloved Google, and thanks to his Google Earth, I divided the area in 16 different zones. Then I made a full screenshot of each of them, and I merged them into a unique texture with the help of Photoshop. But at this point, there is another issue. I have a huge area and a low detailed texture. So user sees that I have a low texture. So what can I do? I reiterate the process and obtain other two models, one 25 by 25 kilometers and one 12 by 12 kilometers. And what I've done with Google Earth is to take the 4 central zones and divide them in 16 zones, then take a full screenshot of them, and so on, and then the 4 central in other 16 centrals. So I get even more deeply, even in more depth, the screenshots. So this is the final result. I have 3 different areas. The widest one that is 60 by 60 and has the low definition texture. The middle one that is the one highlighted, and the last one, which is the smallest one, but the one with the highest resolution texture. And obviously all the experience happens above this last one area. So even in such small project, there are a lot of things to say and discuss, but I choose to talk to you about only the most uncommon ones. I really thank you for your attention. I hope you enjoyed. If there is any question, I'm here at your completely disposal, so thank you.
Thanks, Francesco. This was extremely interesting. We have
some
time.
time.
2020. Okay, we have 5 minutes of questions. Who wanna start?
Hi, thank you for your presentation. Do you think that cyber sickness problems will be solved entirely by how to say software tricks, or there is an inherent problem with this kind of technology? Because I've tried on myself, and actually I had some kind of cyber sickness.
May I ask you if you have tried the HTC Vive or
just Samsung Wear?
Okay, because
I don't know how it's different.
yeah,
Yes.
it's a little bit different, but your question is right, because the requirements I explained to you can reduce the cyber sickness, but not avoid it, because the vestibular stimuli still missing. So I asked you if you have tried the HTC Vive, because the HTC Vive allows you to move in your room. So moving in your room actually gives you also the vestibular stimuli. So you get rid of this issue with the HTC Vive. While if you use the Samsung VR or the Oculus Rift, I mean the development kit 2, that is the one I had for my thesis, you cannot go around your room, so the issues is already here. But there are some tricks to reduce it, but you cannot avoid it if you cannot move. There are some studies that are trying to avoid it by electrically stimulating the vestibular organs, but they are not spread yet. So I mean, even if you are sick, they gives you electrical stimuli, but it's not a research so advanced now. So there are some researches, but you know, there are also some tools, some devices that allows you to walk in place, like how it's called, like a tapirulan, yeah, that allows you to walk and rest in place, but they are huge and they are expensive, so companies are trying to find something else out.
Any more
Yes,
questions?
yes, another question.
If anyone, just raise your hand.
The causes that you described are related also to what some people feel when they, for example, watch movies in 3D at cinema, or it's a totally different thing?
Really, it's a little bit different, because I don't know if you know how the 3D cinema works. Or you can having some filters on the lens, or the most advanced one has the lens that at every frame one covers the eye alternatively. So it's not a problem of the vestibular stimuli, but it's a problem of that our brain understand that something's going wrong with our sight, and so he blows up, but they are not related. The issues are the same, but the problem at the root is not.
Thank you.
Somebody else that wants to hear vestibular stimuli from our speaker? Any other question? Now or never? Okay. Oh, last one.
So are people that are already affected by motion sickness, like in boats or a car, more affected by this type of sickness too, or it is unrelated?
Actually, I think that they suffer more, because I have a friend which tried my application, and he has the issues you are talking about, and I noticed that he suffers more the application. So I think that there is some correlations, but I don't really know the intensity of this correlation. But I think there is some.
That's it. Okay, I know that you might not want to ask any other question because you want to eat.
Guys, look at this guy.
Another applause.
When he was in Impact Hub, he was this tall, he couldn't barely speak, and now, wonderful presentation, big applause everyone. Yeah. Thank you very much.
So,
Couple of things.
Yeah.
So, first one, there's a giveaway, which is not spam, but it is. We are giving a free t-shirt for the highest score in Tricky Traps. Hashtag Tricky Traps on Twitter. Highest score wins a Becca t-shirt. This one won the spam one. The other one is Let's Make a Magic. Some of you have a PhD, so I'm sure you can put chairs on other chairs. Yeah, I'm sure you do.
Yeah,
Make a stack. Yeah.
I'm sure you're pretty good at
FIFO or LIFO or.
First of all, before closing up, another big applause to our photographer, Giulia. Yeah, that's enough. Okay.
Stop it, please.
Another big applause to all the Speck&Tech team here and all the helpers and whoever. Final remark. We have Giulio for Berka and Tricky Traps questions, whatever you're interested in. If you're interested in startup days, just come at me. If you're interested in augmented reality and working at Horus, there's LUCA over there. And if you're interested in Practix, the two guys are over there. It's a really good opportunity, guys. We're giving you a job. So this is what we're trying to do. This is Speck&Tech.
And the surprising thing is that it's paid. So
yeah. And the surprising thing is that now let's enjoy the break and let's enjoy the food.
Yeah, but first let's stack chairs, everyone. Yes, sir.
No, io faccio più ma questo è costruito. Dove la poni?
It is a lovely stack indeed.
Don't worry, the spec is coming.
Aggrediamo quella zona noi.
Grazie Franz.
Sì,
Io canto.
ma infatti guarda, non so se farla perché è molto stupido. E lei la fa di tensione. Perché dicono che sapevo che alla fine mi veniva.
Are you going back to your house or stay here for food? I don't know why I spent 2 days in Bolzano taking cold and cold and cold because I had only a jacket and nothing else, and I'm okay. So probably I have going to bed or feel hot and then I feel sick probably. It could be possible. First time I met him, he was reading his thesis, and he was a brilliant eyes showing me the situation. So when he told me you have to come, I was really glad to come here to think about this. And really good presentation. The video was amazing. Yeah, really. At the beginning, I feel
no, anche perché dobbiamo fare
when you're on the top, it was amazing. Really interesting. Very nice.
Sono sicuro che sempre sarai la battaglia di oggi mi è piaciuta molto.
Ciao a tutti.
Ciao a tutti.